Imagine building your own automated smart home, a live weather station, or a robotic arm right on your desk. The biggest barrier for most beginners is figuring out how to bridge the gap between wiring physical electronics and writing software code. That is exactly where Arduino comes in. It is an open-source platform designed to make connecting hardware and software accessible for rapid prototyping. By the end of this video, you will have a complete conceptual blueprint to map, wire, and program your very first automated system. Methodical. This diagram shows the standard baseline board for almost all beginner projects, the Arduino UNO. Let's look at its physical anatomy. Right in the middle is the microcontroller. This is the actual brain of the board, where all your logic and memory reside. To interact with the outside world, this brain uses a nervous system of digital and analog pins. To run safely, the power supply and voltage regulator step down power to feed these delicate electronics. Finally, the crystal oscillator acts as the system's heartbeat, keeping precise time so all processing tasks stay synchronized. But here is the catch. This physical board is entirely useless on its own. It is a blank slate until we give it a workflow and a specific set of instructions. This flowchart illustrates the core logic of all automation. It is a strict linear workflow moving from input to processing directly to output. Inputs are your data gatherers, like a sensor reading room temperature or detecting human motion. That data feeds into the processing phase, where the Arduino evaluates sensor readings against the rules in its memory. If met, it triggers an output, executing a physical decision like clicking a relay, spinning a motor, or printing text on a screen. Whether you are wiring a simple nightlight or programming a complex industrial assembly line, this underlying architectural workflow remains exactly the same. To write those rules, we use this interface, the open-source Arduino IDE. Think of it as a translator, turning human intent into machine-readable instructions. Every Arduino program, called a sketch, is strictly divided into two distinct manageable blocks. The first is the setup function. This initialization phase runs exactly once when the board powers on, declaring which hardware is connected to which pins. The second is the loop function. This is the continuous operational cycle. It constantly reads sensors and updates outputs over and over, as long as the board has power. Uploading this code via a USB cable gives you direct control over your hardware's physical behavior. You can even read live sensor data back to your computer using a tool called the serial monitor to verify your success. You will notice different form factors. Scale projects down with the tiny Arduino Nano or scale up with the massive Arduino Mega. To bring your projects online, you will need to add specific communication modules or switch to boards like the ESP32 and ESP8266, which have Wi-Fi and Bluetooth built right in. This brings us to a common point of confusion for beginners. This diagram compares an Arduino, which is a microcontroller, with a Raspberry Pi, which is a microcomputer. The Arduino has low memory and no operating system, meaning it executes simple, real-time commands perfectly. But it lacks the processing power for heavy data crunching or AI, tasks where the Raspberry Pi excels. Because of these traits, Arduino is ideal for tasks requiring immediate physical reflexes, such as triggering smart lighting, running basic robotics, and operating smart parking sensors. Understanding these hardware limitations is the critical first step to ensuring your prototype functions reliably when you deploy it in the real world. You now have the conceptual framework to get started. You know the hardware anatomy, how to map the sensor workflow, and how to structure your code in the IDE. This basic logic of inputs and outputs serves as the essential first building block for understanding industrial IoT and smart manufacturing. Ready for professional industrial-grade systems? DEVI Automation Solutions is your partner. We provide PLC programming, SCADA, VFD drives, AI, and solar energy solutions. Email us today for project support. Like, comment your project idea, and subscribe for more tutorials.